The crafting genius is here. After 90 days of hard work, they've created the internet's largest Boeing 777 remote-controlled model, featuring an all-carbon fiber body, dual-engine power, and a complete flight control system. This isn't just a model airplane, it's a hardcore craftsman's ultimate challenge to the aviation industry. Get ready, because we're diving in and going all the way. Here's the fuselage structure carved out using a foam cutting machine. All the segmented foam pieces are assembled and bonded together. Given the massive size of this airplane design, using foam boards is key to keeping it lightweight. This is the assembled foam fuselage structure. So, how do we ensure the strength and rigidity of the entire body? The answer is spraying a layer of ABS material over the surface. This material boasts high heat resistance, great strength, and stable chemical properties. Once it solidifies, it's time for putty application and sanding. But looking at this ultra-long fuselage, this is undeniably a massive production. A square hole is cut in the middle of the fuselage to reserve space for the installation of electronic control components. This hole also allows for reinforcing the interior with carbon fiber. Next up is the construction of the rear tail wing. The assembled connecting framework is embedded into the wing panel. Then, using premium carbon fiber, worth 500 grams per half kilo, the entire surface of the wing panel is covered. Here's how it's done. Looks pretty straightforward, right? Next, we cut and separate the rudder surface structure. This is the making of the vertical tail. With the installation of a hidden servo linkage, the rudder's operation is controlled by a servo and linkage connected to the rudder surface, enabling precise electric control of the rudder angle. A power-on test checks the rudder's swing angle, and it's connected to the fuselage through pre-reserved mounting holes. Doesn't it look absolutely perfect? Now, onto the two main wings, the most complex and challenging part of the build. As before, the carved segmented structures are assembled. For the stress-bearing areas of the fuselage, a wooden framework combined with carbon tubes is embedded for reinforcement. This is the connecting frame for the two wings, made from thickened carbon plates. Here's how it's done. The entire construction not only needs to be structurally sound, but also must maximize lightweight design. The wing surfaces are then smoothed and refined for a flawless finish. This lays the groundwork for the next step of carbon fiber covering. Additionally, the internal wiring for the wing panels needs to be pre-installed. What seems like a complex operation is, in fact, far from simple. With the internal wing work completed, it's time to cover the entire surface with carbon fiber. The reason carbon fiber is so expensive and highly valued lies in its complex production process and exceptional physical properties: high strength, lightweight, and heat resistance. These qualities make it a material heavily utilized in the aviation industry. First, a docking test between the wings and the fuselage is conducted. The internal structure is meticulously reinforced to prevent the aircraft from disintegrating during high-speed flight. This is the framework for the front landing gear, where the horizontal alignment is carefully calibrated before being secured with adhesive. The rear landing gear is installed at the front of the wings, arranged in a symmetrical left-right layout. With these steps complete, the basic structure of the aircraft takes shape, looking incredibly impressive. Next up is the cutting and design of the control surfaces on the wings. Pay close attention to the master's detailed craftsmanship. The control surfaces and wing panels are connected using carbon plate hinges, which demand exceptional craftsmanship to achieve precise rudder alignment. Each control surface is paired with a servo, and a power-on test is conducted to check their basic operation. This setup fully replicates all the control components of a real aircraft, including flaps, ailerons, and spoilers. The wingtip structures, which can be electrically deployed and retracted, are created using a 3D printer for the connecting components. Pay close attention to the master's meticulous techniques. With these steps complete, a high-tech electrically controlled wingtip is finished. Next, a groove is cut into the wing panel to embed a carbon plate, laying the foundation for engine installation. Check out this massive turbofan. Doesn't it look incredibly powerful? The thrust is absolutely ferocious. Now, it's time to craft the engine nacelle. Using a combination of foam boards and carbon fiber, the structure is carefully shaped. Doesn't it look strikingly realistic? Every step of the process is so smooth and flawless. The front windshield is also given a hollowed-out transparent treatment. Completing the aircraft's external structure. The next step is installing the electronic controls, starting with carefully planning the wiring layout for all the control components. A carbon plate is carved to securely arrange and fix all the components. This is the core brain of the entire aircraft and represents the biggest investment in the build. Can you all figure out what these components are? Next, we test the turbofan motor's operation. The electronic control components are installed inside the fuselage. All the wiring is connected, and the remote controller is used to program each channel's controls. The landing gear looks incredibly high-end, doesn't it? With that, the aircraft structure and electronic components are fully installed. Seeing such a stunning high-tech model aircraft, isn't it absolutely mind-blowing? Of course, the critical question is whether it can successfully take off and how closely it can replicate the real aircraft's performance. That's where the final painting and coating come in. Here's the finished product. Take a moment to quietly admire it. It's just too cool. Which guy wouldn't want to own one of these? So, can it soar into the skies? Here comes the moment of true liftoff. It's rocketing into the sky. What an incredible feat. Retracting the landing gear. It's time to show off a slick low-altitude flyby. I've got to say, this thing is seriously fun to play with, and you can even experience the thrill of soaring through the skies from a first-person perspective. Now, let's see how it handles landing. That braking effect is phenomenal. From crafting to test flight, it's nothing short of perfection. So, have you all learned how to create such an epic handmade masterpiece?